Sketch the graph of the function f of x equals sine of x times cosine of x on the interval 0 to pi. We will follow the guidelines for curve sketching. First, the domain of this function is the set of all real numbers, except that we are restricted from the interval 0 to pi. Next, to find the y-intercept, we simply evaluate this function at 0. Sine of 0 times cosine of 0 is 0 times 1, which is 0. The y-intercept is x equals 0, y equals 0, and this is also the x-intercept. To find the x-intercept, there might be more than one x-intercept, but there is only one y-intercept. We set sine of x times cosine of x equals 0. This is the zero product, so each of the factors can be 0. Sine of x equals 0 when x equals 0 and x equals pi. Cosine of x equals 0 when x equals pi over 2 and 3 pi over 2, but 3 pi over 2 is not in the domain. So we see that the x-intercepts are when x equals 0, y equals 0, when x equals pi over 2, y equals 0, and when x equals pi, y equals 0. So there are 3 x-intercepts and 1 y-intercept. To determine any symmetry of the graph, we simply evaluate f of negative x. F of negative x is sine of negative x times cosine of negative x, but sine of x is an odd function, so sine of negative x is negative sine of x. Cosine is an even function, so cosine of negative x is cosine of x. This gives us back negative f of x to show that this function is odd. If we plug in negative x and the output is negative of the original function, then the function is odd. What this means is that whatever we have on the right hand side of 0, we will simply have a reflection over the origin, across the origin, or about the origin. For asymptote, we know that this function will not have any vertical asymptote because f of x is defined everywhere on this interval. For the horizontal asymptote, we would need to evaluate the limit at x goes to infinity, but at x goes to infinity, sine of x and cosine of x oscillate and it will not go toward any number, so there is no horizontal asymptote in this case. To find the interval where the function is increasing or decreasing, we would need to know the first derivative. Using the product rule, the first derivative is, we have two factors here, sine of x and cosine of x. Using the product rule, we have the derivative of sine of x is cosine of x times the second factor, plus we keep the first factor, multiply the derivative of the second factor. The derivative of cosine of x is negative sine of x, so we have cosine squared of x minus sine squared of x. And we know that this is an identity. This is cosine of 2x, the double angle identity. Set it equal to 0. We see that cosine of 2x is 0 only when the argument of cosine, we saw this earlier, cosine is 0 only when the input is pi over 2 or 3 pi over 2. But to isolate x, we have x equals pi over 4 and x equals 3 pi over 4. 3 pi over 4 is still in the interval 0 to pi, so we would need it. There are two zeros for the first derivative. These are the critical numbers. We will use these numbers as cut points to determine the interval where the function is increasing or decreasing, but we will do that in a minute once we have the zeros of the second derivative as well. For the second derivative, f double prime, Using the simplified version of f prime of x is cosine of 2x. So f double prime of x is negative sine of 2x times 2, which is negative 2 sine of 2x, and we set it equal to 0. Divide both sides by negative 2. We have sine of 2x equals 0. Sine is 0 when the input is 0 or pi or 2 pi. If 2x is 0, then x equals 0. 2x equals pi, x equals pi over 2. And 2x equals 2 pi, x equals pi. Pi is still in the closed interval 0 to pi, so we would need it as well. The second derivative is 0 at 0, pi over 2 pi, although 0 and pi are the endpoints. Armed with these cut points, we now construct the sign chart for f prime and f double prime. For f prime, the cut points are pi over 4 and 3 pi over 4. Pi over 4 is between 0 and pi over 2, and 3 pi over 4 is between pi over 2 and pi. We then pick any number between 0 and pi over 4 and plugged it into the first derivative, pi over 6, for instance. Cosine of 2 times pi over 6. 2 times pi over 6 is pi over 3, and cosine of pi over 3 is positive. So the first derivative is positive from 0 to pi over 4. Pick any number from pi over 4 to 3 pi over 4, pi over 2 for instance, and plug it into the first derivative. Cosine of 2 times pi over 2 is cosine of pi. Cosine of pi is negative. Pick any number between 3 pi over 4 and pi, such that 5 pi over 6 into the first derivative. We see that cosine of 2 times 5 pi over 6 is cosine of 5 pi over 3. And cosine of 5 pi over 3 is positive. So the function is increasing from 0 to pi over 4, decreasing from pi over 4 to 3 pi over 4, and increasing from 3 pi over 4 to pi. For the second derivative, from 0 to pi, the cut points are pi over 2, 0, and pi. Pick any number between 0 and pi over 2, pi over 4 for instance, and plug it into the second derivative. The second derivative is negative 2 times sine of 2x. If we plug in pi over 4, 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. Negative 2 times 1 is negative. So the second derivative is negative on the interval 0 to pi over 2. Pick a number between pi over 2 and pi, 3 pi over 4 for instance. Plug it in there. We see that for the second derivative, negative 2 times sine of 2 times 3 pi over 4. This is negative 2 times sine of 3 pi over 2. But sine of 3 pi over 2 is negative 1, and negative 2 times negative 1 is positive. So the function is concave down from 0 to pi over 2, and concave up from pi over 2 to pi. With this and the x-intercept as 0 at pi over 2 and at pi, we now sketch the graph of f. To sketch the graph of f, we first plot the points that belong to the function f. They are the x-intercept and the y-intercept and any local maximum and minimum. We know that the x-intercepts are 0, at pi over 2, and at pi. The function has the local maximum at pi over 4, so we evaluate the function f of x equals sine of x cosine of x at pi over 4. This is sine of pi over 4 times cosine of pi over 4, which is root 2 over 2 times root 2 over 2, or 2 over 4, or 1/2. When x equals pi over 4, the local maximum is 1/2. There is a local minimum at 3 pi over 4, so we would evaluate f of 3 pi over 4 to obtain sine of 3 pi over 4 times cosine of 3 pi over 4. But this is root 2 over 2 positive, cosine of 3 pi over 4 is negative root 2 over 2 negative, so this is negative 1/2. When x is 3 pi over 4, y is negative 1/2, and this will be the local minimum. We now plot the graph of f. From 0 to pi over 4, the function is increasing and concave down. From pi over 4 to pi over 2, the function is decreasing and concave down. From pi over 2 to 3 pi over 4, f is decreasing and concave up. And from 3 pi over 4 to pi, the function is increasing and concave up. The graph has to go through these points. First, from 0 to pi over 4, it is increasing and concave down. From pi over 4 to pi over 4, it is decreasing and concave down. From pi over 2 to 3 pi over 4, it is decreasing and concave up. From 3 pi over 4 to pi, it is increasing and concave up. We see that the graph of f has an inflection point at x equals pi over 2, because that is where the second derivative changes its sign, but this is also the x-intercept that we evaluated as well.